Hello, Tani. Hello. Yes, good evening, Bhavesh.
Good
Good
evening, ma'am.
evening, Tani. Good evening, children. Put on the videos. Yes, put your video on. Great. Okay, so let's begin.
Good evening, ma'am.
Good evening, Tani. Okay, let's see, children. Today we are about to start whole numbers. Right? Hello. Today we are starting a new chapter that is whole numbers.
Okay, ma'am.
Okay, so let's begin. Whole numbers, right? Now, you know what are whole numbers? Can anyone tell me what are natural numbers first? What are natural numbers?
Natural numbers are the numbers which start from 0.
Zero.
Yes, ma'am.
Okay.
No. Ma'am, 1. Ma'am, from 1. From 1, ma'am.
Okay. So natural numbers are those numbers which start from 1, 2, 3, 4, so on till infinity, right? And if we add 0 to it, and if we take one more number 0 with this 0, 1, 2, 3, 4, and so on. If 0 includes in this list, then we call this set of numbers as
Ma'am,
whole.
whole.
Okay. If 0 adds to this list of numbers, we call them as whole numbers. Now whole numbers start from 0, 1, 2, 3, so on. Right? So this chapter is all about whole numbers. Okay. Now here we will study one more term, predecessor and successor. Predecessor, and there is another term, successor. Has anyone heard about it earlier?
Ma'am, predecessor is previous number.
The number which comes before. Okay, successor is number which comes after.
After.
Small in your junior classes, you must have studied, no? A number before, a number after. Is that? Now suppose if I give you one number 100. So what is the predecessor of 100? Predecessor of 100 will be one number before
99.
99. Okay, so predecessor of this number will be, you will just minus 1 here, you will get 99. And if you want the successor of this number, if you have 100, successor means a number after. So you just add 1 to it, you will get 101. Right? Predecessor is one number before, successor is one number after. Suppose if you have a number 58, its predecessor will be, you subtract 1 from here, you get the previous number. Successor is, if your number is 58, you add 1 to it, you get the next number. Okay, that is the successor. Successor means something which comes after, right? Okay, children?
Good morning, ma'am.
Good morning, Beta. So this is the concept of predecessor and successor. Okay? Okay. Now, adding of whole numbers, subtracting of whole numbers, this is just the same thing that you have been doing in your junior classes. Okay? You add whole numbers if you have 343 and you have 654. So that's the same thing. Okay? Just simple. These are numbers. Right? Same way we have addition of subtraction of these numbers. We have multiplication of these numbers. And how do we take them on the number line? That's the very simple thing that you have been doing in your junior classes. Okay, just taking the one from here. The 0 is here. Suppose if you want 8 on the number line, so you will draw 8 points here. So you just take 1, 2, 3, 4, 5, 6, 7. Next one is 8. Okay, so you will take one step and finally you will reach point 8. Okay, there is nothing new about it. So let's come to the questions part. Okay, let's do some questions. Okay, the first question is, write the next 3 natural numbers after 1999. Write next 3 natural numbers next 3 natural numbers after 10,999. Now write the next 3 natural numbers after this. What do you think would be the next 3 natural numbers? You add 1 to it, you get your next number. You add 1 to that number, you will get your next number. Then you add 1 more to it, you'll get your next number. Do it.
Done, ma'am. I'm done.
What are the numbers? Tell me
Uh,
what.
1 minute, ma'am. I didn't write the last one. 11,000.
Yes.
11,001.
Okay.
11,002.
Great. Okay, so these are the 3 numbers: 11,001, 11,000, 11,001, 11,002. Right? Okay. So now I have one more question. Write 3 whole numbers occurring just before 10,001. Now Tani will give me this answer. Do it. Write 3 whole numbers occurring just before. Numbers before. Give me 3 numbers before this number. Yes, Tani. Bhavesh, you tell me.
10,000.
Yes, very good. 10,000.
After it, 49.
9,999. Yes.
After that, 999 and 8.
Yes. So that is 9,998.
Yes, ma'am.
Okay. Which is the smallest whole number, Bhavesh?
Smallest whole number is ma'am 1.
Which is the smallest whole number? See,
0.
here we were saying no, whole number starts from 0 onwards. So which is the smallest whole number?
0.
0. Yes. Yes, what is the doubt about it? Smallest whole number, this is the whole set of whole numbers. Whole numbers start from 0, 1, 2, 3, so on. So smallest number here is 0, no? Okay. Yes, children? Okay. Write the predecessor. Now you have to write the predecessor. Just now I showed you what are predecessors. So write the predecessor of 208090. Right. 2,08,090. One more. Yes. Lakshita, tell me the predecessor of this A1.
Um, 1 moment. It is like what's I made a mistake on it. Um, 2,08,089.
Yes. Good. You just have to subtract 1 from this. Okay. Don't be so doubtful. Okay. Now, Bhavesh, tell me the predecessor of this number.
B1.
This one. Yes, B part.
Yes, ma'am. 76 lakh
Hmm.
54,320.
Hmm. Good. Okay. So you just have to subtract 1 from here. Very nice. Okay. Now we'll see properties of whole numbers. Okay. Now there are some numbers also have some properties. Okay. So we'll see properties of whole numbers. Okay, so first property that we will see is closure property. The first property is called closure property. Okay, now what does this closure property tells us? Closure property, look here, the closure property tells us that if we add two whole numbers, the answer we get is also a whole number. Okay, the sum of two whole numbers is also a whole number. That means if we are adding two whole numbers, suppose if I have some number, I can take with the example like this, 8 plus 5. So whatever answer I get will also be a whole number. Okay. Okay. So what does the closure property say? That sum of, hello? Hello children, are you there?
Yes,
Yes,
ma'am.
So why your videos have gone off? Sum of two whole numbers is a whole number. Okay. Sum of two whole numbers is a whole number. So if I added two whole numbers, my answer is also a whole number. This is what the closure property tells us. Okay. And it holds true for addition also. It holds true for multiplication also. Suppose in multiply, I take two whole numbers and I multiply them. You can take any number of your choice. 2 into 3 gives me 6. So 6 is also a whole number. 2 was a whole number, 3 was a whole number, 6 is also a whole number. Right? So this closure property holds true for addition and multiplication. So we have seen in both cases, in multiplication and addition also. Okay. So closure property holds true.
Can you give another example?
Huh?
Can you give another example, ma'am?
Yes, we'll take another example. Holds true for addition and multiplication. So we have seen for multiplication part also. See, I'll show you with more example. Suppose if you have number 24, you have number 36. When you add them, what do you get?
60.
60. So 60 is also a whole number. When you are adding two whole numbers, your answer is also coming as a whole number only. Okay. Similarly, if you multiply some whole number, if you multiply any number with 0, you get your answer as 0. Isn't that? If you
Yes, ma'am.
multiply any number with 1, you get the same number. 0 is a whole number, 9 is a whole number. Right? If you
Yes.
multiply 25 with 3, you get 75. So 75 here is also a whole number. Right? So if you multiply a whole number with another whole number, you get your answer is also a whole number. Okay, and it holds true for addition and multiplication. Okay. Okay, now let's do commutative property. This is commutative property over addition and multiplication. We'll see together addition and multiplication. Now, but what this commutative property tells us? Commutative property tells us that if I have two numbers written in any order, like if I have two numbers 2 plus 3, I can change the order also. Even by changing the order, I will get the same answer. 2 plus 3 is 5, 3 plus 2 is also 5. So if I add two whole numbers, okay, I get the same. If I add two whole numbers in any order, here the main important thing is in any order, I get the same answer. This is what the commutative property tells us. Okay, so let's see with more examples. If I take 6 plus 11, can I write this as 11 plus 6? 6 plus 11 is 17. 11 plus 6 is also 17. Right? Are you getting? Are you
Yes.
understanding this?
Yes,
Suppose if I have 5 multiply with 3, we are doing for multiplication also. No? Let's see for multiplication also. So 5 is a whole number, 3 is a whole number. If I multiply these two, I get 15. So 15 is also a whole number. Right? If I take 6 into 4, so I get a whole, I have whole numbers getting multiplied. So my answer is also a whole number. Okay, so we found that commutative property holds true for addition and multiplication. Right? Commutative property holds true for addition and multiplication. Okay. Yes, children, this is commutative property that if you add any numbers, if you add two numbers in any order, you get the same result. Okay. I hope it's
Okay.
clear.
Yes, ma'am.
Clear to all, Lakshita?
Yes, ma'am.
Okay. Now coming to associative property. In associative property, we take three numbers. Associative property for addition and multiplication. In associative property, we take three numbers. Okay, suppose if I have three numbers, say 6 plus 9 grouped in any order. If I have three numbers grouped in any order, here the thing grouped in any order, this is the main word. Okay. So I get this, even if I change the order of grouping, I get the same answer. This is what it says. Associative property is like this. If you have three numbers, you group them in any order and add them, the answer comes the same. Okay?
Okay, ma'am.
If you have three integers grouped in any order, your answer is the same. So same way, let's do for multiplication also. Let's check for multiplication. If I have 2 multiply 5 multiply by 7. So what do I get?
I'm 70.
So here I have 2 into like this 5 multiplied by 7. What do I get?
I'm again 70.
So this is 10 into 7, 70. And this is 35 into 2, 70. Okay? Okay, children?
Yes, ma'am.
I hope you are understanding this. So in this case also, we say that associative property holds true for addition and multiplication. So we studied here three properties: closure property, commutative property, and associative property. And we found that three of them holds true for addition and multiplication. Okay? Okay?
Yes, ma'am.
Okay, now coming to the next property, that is distributivity of multiplication over addition. Now this is something slightly different because in this we have two signs. This is called distributive property. So this is distributivity of multiplication over addition. Now what does this mean? Multiplication over addition. Okay, this says that if I have some number, say 5 into 3 into 3 plus 9. Inside the bracket I have plus sign and outside the bracket I have multiply sign. 7 into 3 plus 9 will be equal to, if I multiply 7 with 3 plus 7 with 9, this will be equal to this. This is what my distributive property tells me. That if I have any number multiplied by the addition, okay, now addition of two numbers, it will be equal to first number multiplied by the second number and then first number multiplied by the third number. Okay? All right, are you understanding?
Yes, ma'am.
Yes.
Okay. So this is distributivity of multiplication over addition. Now let's take some other example also and we'll check. 8 into 5 plus 9. That means this will be 8 into 5. First 8 will multiply with this number. Then 8 will multiply with the other number. And in between we will have this plus sign. So that is 8 multiplied by 9. Yes? Okay? So what answer you get with this? 8 5 is 40, 8 9 is 72. 72 plus 40. Okay? Right? Okay. Let's see the next one. Next
what?
is, yes. Yes,
I'm
Ramesh.
Nothing.
Yes, say something. You are saying.
I'm nothing, ma'am.
Okay. Identity for addition and multiplication. Now, what is identity for addition and multiplication? Identity is 0 is the identity for addition and 1 is the identity for multiplication of whole numbers. Identity. Okay. Identity means by adding, if I have any number, if I add 0 to it, my number retains its identity. My number is not losing its identity. It's not that if I add 0 to any number, my number will come out something else. It's not like that. If I add 0, okay, my number will be the same as it was. So this is called additive identity. Why we call it additive identity? Because we are adding, okay, and this is the identity because this is not changing the identity of the original number. So we say 0 is the additive identity. Okay?
For multiplication, is it 1?
Yes. I'm coming on multiplication also. For multiplication, if I have this number, if I multiply this number with 1, I get the same number. So that means here my number did not lose its identity even by multiplying with some number. So that some number is called additive identity. Okay? That when you add and you get the same number. Okay?
Yeah.
So 0 and 1 are identity elements. We call 0 and 1 as identity elements. Okay, like this 0 and 1 are identity elements. Okay. Yes, children. Hello.
Yes, ma'am.
I hope you are understanding this.
Yes, ma'am.
Okay, now let's come to another property, that is division by 0. Can we divide anything by 0?
Yes.
Huh? Can we do? Division by 0, not dividing by 0. It's division by 0.
No, ma'am.
We cannot divide anything by 0. 0 can never be in the denominator. 0 can be in the numerator, but it cannot be in the denominator anyways. Okay? So division by 0. So if I have some number 0 divided by some number 3. So my answer will be 0 only, no? 0 divided by 1,55,240. So much big number, but still my answer will be 0. Okay?
Yes.
With whatever number I divide, my answer will come out to be 0 only. But if I have some number like this, say 20 divided by 0, will that be 0?
No, ma'am.
No, this will be not defined. Okay, this answer will not be 0. This will be not defined. ये तो define ही नहीं हो सकता. We cannot divide only. So if you have denominator in the numerator part, if you have 0, then your answer comes 0. Okay. But if you have 0 in the denominator part, denominator means in a fraction, the upper part is called numerator. Okay. The lower part is called denominator. Okay. So this is 0 divided by 3. If you have 0 in the numerator, then of course your answer will be 0. But if you have 0 in the denominator here, then your answer will be not defined. Okay?
And it's improper fraction.
Yes.
Plus we can't divide it.
Okay, so this will be undefined. You call it undefined, not defined. Dividing by 0 is not defined. Okay. So these were the properties. Let's come to the question part now. We'll get a better understanding by doing some questions, isn't that? Find the sum by suitable rearrangement. Suitable rearrangement means we have to arrange the numbers in such a way that it becomes easy for us to find the sum. Okay? By suitable arrangement. Okay, let's see this one. 837 plus 208 plus 363. Now look here, how you add this number by suitable rearrangement. Rearrangement means you have to arrange these numbers in such a way that your addition becomes easy. So what will you think of? See, how can we make our addition simple? If we have zeros at the end, Suppose if we have 10, 100, 1000 such numbers in the end, isn't that becomes easy for us? Does not that becomes easy for us to solve the question that if I have to add 58 with this will be 2158. This was okay, like this. Isn't that easy? If you do like this. So this was just to explain you. Now if I take this 837 and 208, what is 830? Just imagine what would be 837 and 208. Will that be some rounded off figure? 87 will be 56, 5, 15. Okay, then this comes 4, this comes 10. That means becomes 1445. Okay, so let's think of something else. If I have 837 added with 363, suppose if I add these two and this one I add afterwards, then what I get? 837 plus 363. What do I get? 7 plus 3 will be 10. 6 plus 3 is 9 plus 1 more is 10. Okay, I get 9, then 10, 11, 12. So I got 1200. Okay. Now 1200 plus 208. Is that a little bit easy to add?
Yes, ma'am.
0 plus 8 will be 8. Now in tens place we have just zeros. Then 2 plus 2 is 4. Like this. Okay. This is what we get.
Yes, ma'am.
Yes? Okay.
Yes, ma'am.
Okay, good with it. Now I'll give you one sum for multiply like this by suitable rearrangement. Okay, multiply by suitable rearrangement. So this is 2 into 1768, 1768 into 50. Now, what do you think? So, what suitable arrangement we will find so that our multiplication becomes easy?
50 times 1768, then multiply by 2.
Who is saying this? Lakshita, Bhavesh?
Laksh.
Okay, see here, if I have to add this with 50, this will become some number, no? And 1 0 with that. And then again, I will multiply with 2. So, what if I just multiply 2 and 50 together? And then I multiply this with 1768. How would that be? I can say 2 into 50 is 100. We all know that. Isn't that 50 ka double is 100? And
Yes.
then we multiply this 1768. That means if I multiply this number with
Ma'am,
100,
we'll get
just,
17.
yes, I just have to put 2 zeros here.
I
did
just
not
got
do any rough work here to multiply, isn't that?
Yes, ma'am.
Okay. Now same way, let's do one more. This is the last question. Then our class time is getting over. 125. Now see, in this case also, what can we see? I can see that if I multiply 8 with 5, this will give me some 0 in the ones place.
Then we can easily keep 0 to the next
8
one.
5 is 40, then 8 4 is 30, 8 2 is 16, 16 plus 4 becomes 20. Then 8 1 is 8 plus 2, 10. This became 1000. Now 1000.
Ma'am, simply we
How did
should
I
add
get
3
1000?
zeros.
By multiplying 8 into 125. And then I will multiply that with 291. Okay, so that becomes 1000 multiplied by 291. Now I don't have to do anything. 291 into 1 is 291. And
I can just blindly keep 3 zeros
right?
at the end.
Okay, children?
Yes, ma'am.
I hope you are understanding it. When we have zeros, no, like this 10, 100, 50, if we make some number in this form, then that makes our multiplication, our calculation easy. Okay?
Yes, ma'am.
Great. So, winding up the class now, the class time is over. Okay, in the evening, late in the evening, I'll post some homework for you. Okay, of this type of sums.
Ma'am.
Right? Yes. Yes, what happened?
I have notes, ma'am. These notes, are you gonna send me?
Yes, this chapter I will send you. Okay, as I said the previous one, this one also I will send you. Right? I'll send you today only.
Ma'am, in the homework, there were mistakes, ma'am.
Okay. I've
So,
not seen yet. Okay. In the questions there were mistake.
yes, ma'am.
What mistake?
So for the Roman number, you have to write it in Arabic form, right, ma'am?
Huh.
So LVX was a wrong,
Okay.
it was wrong.
Okay. I'll check out better. Maybe it was a wrong
And
side.
what should we do for the like 13 times 108 like brackets?
That is with the suitable rearrangement only. 13 times 108. See, for this is like this only. And 108 can be written as like this, 100 plus 8. Now here you can apply your distributive property that we studied just today. 13 into 100 plus 13 into 8. So 13 into 100 will give me 1300. And when I multiply 13 with 8, I get, what is 13 multiplied by 8?
13 times 8 is
8 3 is 24.
like 104.
102.
104.
104 like this. Okay. So now you can add both of them. So you get 4041. This is your answer.
Ma'am,
Right?
I did like 10 plus 3 in brackets times 100 plus 8 in brackets.
That is also okay. That is also you applied the distributive law only. But in that case, the number was just small. So if you could do with this number, that would make your calculation more easy, even more easy.
Okay.
Okay. Good. Okay. Thank you for today, children.
Thank you,
Bye bye.
ma'am.
Bye, beta.
Thank you, ma'am. Bye,
Bye.
ma'am.
Bye. Good evening.